Hi, I'm Dr. Ray Klump, and I am Associate Dean of the College of Aviation Science and Technology. But more importantly, I'm a professor of engineering, computer, and mathematical sciences here. And I'm so proud and happy to be with you today to talk about the various opportunities, the many opportunities that you have here or would have here as a student in our department. Obviously, you know that there's a need for computing professionals and mathematicians, and that need has never been greater. It's unbelievable how in need we are of the expertise that we teach in this department. Just as an example, this is an estimate of how much data is floating out there on the internet or residing on servers. This equates to 40 million terabyte hard drives, which is just unbelievable. It's hard to even wrap your brain around that. So there's so much data out there, but the stark reality is that very little of it is actually useful and usable. So this is an estimate. It's estimated that only about 25% of the data that's out there is actually usable if tagged and analyzed. It is if we took the time to identify it and actually analyze or figure out what it actually means. Only about a quarter of those 40 million terabyte hard drives would actually be of any consequence. So far, we've made a very small dent in that stockpile of hard drives. We've only classified or figured out 3% of that data as far as what it means. And then furthermore, we haven't actually figured out exactly what it means. We haven't drawn any conclusions from it, except for about a paltry 0.5% of that data. Do we have any idea what it actually means, what it actually amounts to in terms of information? So there's a big data gap, and that translates into you. It translates into your role. There is a great unmet need. So if you prepare yourself, and if we can help you prepare yourselves, you can really take advantage of this situation to your great benefit. You can become part of the people who turn all this useless information, this useless data right now, into stuff that we can act upon. And so you will play a crucial role in tomorrow's society if you can actually meet this goal. And so to that end, in order to help prepare you for that situation, in order to help prepare you to take advantage of these opportunities, we offer many high-quality programs within this single department. And I can't emphasize enough the importance of having a single department deliver all these, because we faculty are a very close, tight-knit group. We meet regularly. We figure out, based on our experiences with you in our various classes, what you most need, and then we act upon it to build new programs or change existing programs in ways that benefit you, that are tailored to your particular needs and academic expectations. This is just a list of all the various programs we offer. And I'm going to start out by talking about one of these, computer science. Computer science is currently our largest program, and it offers 6 concentrations, so 6 ways to specialize in computer science beyond just choosing computer science. You'll see that most of these revolve around programming, applied programming, secure programming, game and simulation programming, systems programming. We also have concentrations in artificial intelligence and mobile computing. This is not to suggest to you that computer science is entirely about programming. That's a very 1960s view of computer science. Computer science is about far more than programming, but because we offer all these other programs within the department, we chose to put most of our programming options within computer science. This is the curriculum for computer science. I'm not going to read this to you or dwell on this with you. You could pause the video and look over it, but you'll see that there's a core set of courses, a good mix of math and computer science. You do need a heavy dose of math because computer science is basically applied mathematics anyway. And there are several programming courses in here too, because programming is the tool that we computer scientists use to describe or discover new knowledge. But then also we have various concentrations, and that's where specific kinds of knowledge are explored more deeply. And so you see the applied programming, secure programming, artificial intelligence, etc. All these different concentrations are available to you by taking just 3 courses. And so you can actually achieve multiple of these concentrations if you have multiple interests in these. Whatever your interests are, you can declare a concentration for that. Take the 3 courses that define that particular concentration and you've achieved that concentration. What good is that? Well, it will appear on your transcript. And because it appears in your transcript, it is something that a potential employer will see and realize that, oh yeah, this person is particularly well cut out for this particular job because they have a concentration in this. So we create these concentrations as a way for you to better differentiate yourself to prospective employers, to say, when you walk in the door, hey, I've got these skills. So this is our computer science major. Now, a variation of that is the computer science plus X programs. These are less rigorous in terms of the computer science requirements, because what they do is they combine the computer science core with various courses or programs in the humanities or social sciences. So right now we partner with political science, theology, music, and history to provide these computer science plus X degrees. They are hybrid degrees. You get most of the coursework in the other program, whether it be history or music, etc., and then most of the core coursework in the computer science curriculum. And what this gives you is an opportunity to apply computer science skills and knowledge and techniques to your other passion, the passion of the X discipline. So this is a really unique kind of offering, one of very few schools that offer it. And we're really proud to offer it to you, because I know that if I were starting out just now, or if this were the 1988 version of me when I was just starting out, I would have totally chosen computer science plus music, but that's just me. You may have interests in other areas. You likely do have other interests in other areas. The computer science plus X programs will therefore appeal to you. For those of you who are less interested in programming but still want a job in computing, we offer a Bachelor of Science in Information Technology. These particular programs primarily focus on ways to enable organizations to manage all the data that they have at their disposal, that is within their reach, and to communicate with that with other organizations or other parts of the same organization. We offer several concentrations in this program as well. So over here are the core set of courses. But over here on the right side, we show you all the different concentrations that you can pursue as an information technology major. Those include networking, project management, data privacy, digital forensics, cybersecurity, and enterprise computing. I'm not going to dwell on any of these, nor am I going to read out this curriculum to you, because that would be boring. But I am going to just suggest to you that this is another really great major, another great option for you, that if programming is not your thing, this is another way to get into the information technology computing space. Now, you notice that one of the concentrations in the information technology degree was cybersecurity. It actually used to be a concentration within computer science. We realized that it might be beneficial to our students if we offered an entirely separate degree in cybersecurity. Not the smallest of reasons for that is that the cybersecurity skills shortage currently tops 4 million people. So it's estimated that 4 million jobs are left unfilled in the cybersecurity space because there aren't enough people with these skills. So we decided to split out our computer science courses that deal with cybersecurity. We decided to split them out into a separate major, and that's the degree program that you see here. Now, this degree program does certainly include lots of programming courses in it too, because if you can't program, you can't really be a top-notch cybersecurity expert, because either A, the cybersecurity problem you're currently dealing with resulted from code that people wrote very poorly, that programmers developed in haste and didn't actually think through all the security implications, or B, it's a result of the great work that hackers have done to figure out innovative ways to break into your system using code. So there certainly is coding in this major, but there are also policy-related programs or courses such as enterprise security and security assessment and risk management. So it's kind of an interdisciplinary degree. Cybersecurity policy and strategy would also fit into the interdisciplinary category. It's not purely a computer science degree, but it is as interdisciplinary as the actual field of cybersecurity is. And so this is a great option for those of you who aren't so interested in software, aren't so interested just in networking perhaps, but you really are interested in cybersecurity. This is the degree for you. One of the great advantages of that degree program is it also gives you a leg up on becoming part of the Lewis Cyber Defense Club. Now, I by no means want to suggest that it is open only to cybersecurity majors. The truth is that the Cyber Defense Club is open to anybody of any major, and in fact, we have members of this club who come from history and other disciplines that would seem to have nothing to do with computer science. And one of the competitions that we've competed in most recently, that we've been most successful in, actually requires a good deal of political science knowledge. But this particular club, this Lewis Cyber Defense Club, has actually placed first in national competitions, including in the 2018 Department of Homeland Security Cyber Defense Competition. And it's made up entirely of students. It is completely student-driven, except for the faculty moderator, Dr. Jason Perry, who does a great job sort of leading and helping these students. But it's an awesome opportunity for those of you who are interested in cybersecurity to get involved with it, to tackle it head on, to learn new things sort of driven by your own imagination and your own interests. And this group of people, and there's 20 other members of this club, have done great things and competed very well at national and local competitions, and we couldn't be prouder of them. We send them on to these competitions through the donations of our generous donors, our alumni, and also through contributions of the university as a whole. So you never have to pay any money to attend these competitions. They're just there for you to compete in and to represent Lewis University well. Next program I want to talk about is data science. As you know, data is a big deal. There's a ton of data out there. I showed you that earlier in this presentation. Lots and lots of exabytes worth of this data, and it's just impossible to wrap your head around, analyze, or to make sense of it all. That's what we mean by big data, this mammoth amount of data that we've collected. How do you actually glean any value from it? Well, to glean value from it, you actually need to analyze it. And that's where our data science program comes in. Our data science program, by offering you a mix of mathematics, statistics, and computer science courses, give you an opportunity to learn how to analyze data, to characterize it, to categorize it, to visualize it, to communicate it. It's a really great program. And it leads you into one of the top jobs in America. According to a number of surveys, it was the #1 job in America, data science was, for the last 4 years. It has a tremendous job score, and part of that job score is the salary. The base salary is $108,000 a year, which is certainly nothing to sneeze at. That is a really great average salary. These are the two programs that lead you to a degree in data science. There's a Bachelor of Arts for those of you who want to also pursue another major as a sort of a double major, so that you can learn all the data science techniques but then apply them to your other major. And there's also the BS in data science for those of you who want to go all in on the data science route. Take all the math and computing you can so that you can apply data science intelligently to any discipline, regardless of what it may be. So we are one of the very few schools that offer undergraduate programs in data science. We also offer and have offered for a long time a graduate program in data science, and this undergraduate program is patterned very closely on that graduate program. So you're getting top-notch, cutting-edge skills that you can enter the workplace with immediately and make a dent, both in a positive dent in your own life, as well as a dent in your organization or the discipline in which you're doing your data science. One of our other really great clubs is Data Science and Artificial Intelligence Laboratory. Dr. Piotr Zurek leads that group. He also leads the data science program as a whole. And what he does is he sponsors or he leads the team in various competitions where they compete against other schools or other people around the world to solve various data science problems. He also helps organize our annual Datathon, which focuses on a particular data-related problem. This past year, in late April, we worked on modeling COVID-19 and its spread, and the top team actually scored an accuracy of 94% on that particular competition. They were able to model the spread of the disease to within 94% accuracy, which is pretty amazing. Students did this, right? You could be part of this. That's what's so amazing about this. With what you'll learn here over the next 4 years, you could actually create a model for the next infectious disease, God forbid, with 94% accuracy. That's amazing. That's fun to think about. Now, we recently changed the name of our department to ECAMS, Engineering, Computing, and Mathematical Sciences, because engineering has become an increasingly large focus, an increasingly important focus of ours over the course of these past few years. Computer engineering started here about 5 years ago. It is an outstanding program that focuses on embedded systems and the Internet of Things. And what this basically means is you are focusing on designing, building, deploying, testing devices that are computer controlled. They respond to sensors, or they respond to inputs in their environment, and in a software powered kind of way respond to those events by actuating motors or electrical impulses or whatever to try to affect change in the world. That's what IoT is about. You're creating, designing, deploying, testing these kinds of devices, and that requires you to become an expert in hardware and software design, testing, and application. It's a truly timely, highly relevant, extremely fun, and hands-on discipline computer engineering is, and it's made possible to you through a really great curriculum that teaches you how to research, design, develop, test, and oversee the manufacture of computer hardware, how to design and test circuits, how to build computer networks, and how to work on the interface between different pieces of hardware. Because as we all know, seldom do you find a single device that operates just as an island, just on its own. Typically, these devices need to interact with other devices, and so as a computer engineer, you learn how to make that happen. So as a computer engineer, you will learn to specialize in artificial intelligence, operating systems, networks, how to design computers and the chips inside of them, including the microprocessors, how to design computer software. You might not become as adept as a computer scientist would be at writing software, but then again, you might become just as good as a computer scientist at writing software. But the point is, the writing of the software wouldn't be for commercial applications you were trying to build, but rather so that you can make the hardware do your bidding, do what it needs to do at any given time to carry out a plan. Where this all comes together, interestingly, is in the field of robotics. We have a robotics lab here on campus that students can use to 3D print the parts for robots, assemble them, actually integrate them with Arduino chips and Raspberry Pis to get them to respond to sensory inputs, and then test the robots. We have a robotics lab here on campus, and what's really cool about the field of robotics is that all this stuff you're learning in the rest of the computer engineering curriculum really comes to play in there. So it's kind of special that Lewis has a robotics lab here that you can use. Another engineering program that we offer that we've added just this past year is electrical engineering. Now, whereas computer engineering specialized on the low voltage side of the spectrum, our electrical engineering program focuses on the exact opposite. We're talking about high voltage electric power systems. How does power get from where it is generated to where it is needed, where it is consumed, where the devices that computer engineers build actually consume that power and turn it into something else. And so to learn about that, you need to learn about transmission, distribution, electric machines, and power electronics. Because without those things, Darth Vader here, as he fights Luke Skywalker, quickly dies out of battery, and then it's no fun for anybody anymore. So we need to keep the lights on. We need to keep the machines humming. That's what electrical engineering is all about. So as an electrical engineer here, you will learn about electric motors, machinery controls, lighting, wiring in buildings, radar navigation systems, communication systems, everything having to do with the generation, transmission, distribution, and control of power. It's a brand new program. It's a very timely program. Any utility would be lining up to hire you. Any industry that has to interface with ComEd or your local utility will be lining up to hire you. You'll have a specialized set of skills that no school our size can offer you. And finally, we have mathematics. Mathematics is our oldest discipline here at Lewis, but it also is arguably our most important, because everything else that we do in ECAMS, everything else that we do in engineering, computing, and mathematical sciences derives from mathematics. Without mathematics, it would all just be guesswork. It would all just be thrown together, and let's just hope and pray that it works. Mathematics gives us some certainty to everything else that we do. But mathematics is a career path in its own right, because what mathematicians learn is that they learn how to solve problems. First and foremost, they are problem solvers. They're problem solvers because they are theorists. They are deeply ingrained with the theory of mathematics, with how numbers work, with how you turn theorems, how you prove theorems and turn them into other theorems that you can prove. They also can analyze data. So the basis of data science comes from mathematics. And mathematicians, therefore, because they are problem solvers, they are in demand in any industry that needs to solve problems. Can you name an industry that can't solve problems? No, definitely not, right? You can't name a single industry that wouldn't need a mathematician, that wouldn't benefit from having a mathematician on staff. Because mathematicians, fundamentally, are people who can solve problems perhaps better than anybody else. And if there's one thing that I regret in my undergraduate schooling is that I didn't minor, at least, in mathematics, let alone double major. If I had done that, there would be a lot more problems that I would be capable of solving without having to just do a lot of trial and guesswork. Mathematicians help cut through that and give you a lot of clarity into solving many of the problems that we need to solve. What's really cool about mathematics here at Lewis is that we have a very tight-knit group of students and faculty. They do a lot of undergraduate research together. They take trips to present their research at various conferences throughout the United States. They have a lot of club-based activities because our math club is extremely organized and effective and energetic. And they engage in lots of summer and during the school year research opportunities. The mathematics curriculum consists of these courses which you'd expect to see in any mathematics curriculum, but we also offer a whole host of specializations, and if you want to roughly divide it, it's divided among statistics, real analysis, and algebra, and so those are the advanced topics that we offer as part of the mathematics curriculum. I would highly recommend taking any of our computing-related programs and combining it with a minor or a major in mathematics because, like I said, it's the only thing that I regret from my schooling. I wish I had done that. Speaking of minors, all of this stuff that I've been throwing at you in the last few minutes can get rather confusing and scary, but if you realize that you can take a major and then combine it with a minor, you're getting the best of both worlds. And so we offer minors in computer science, cybersecurity, data science, and mathematics. This means you can major in computer science and minor in cybersecurity or vice versa, or do the same with data science or mathematics. We offer a lot of flexibility in that regard, and that's one of the advantages of offering everything within one department. We can readily do this. We encourage this. We work with our faculty who are also, by the way, are the advisors. You're going to work with them as your advisors throughout your time here. We work with them to make sure that you're aware of these opportunities to mix and match your interests. And also, looking down the road just a little bit, if you're interested in getting a graduate degree, we offer a fast track to graduate degrees. We call them 4+1 programs. So from any of these undergraduate programs, you can get these graduate program degrees with just one additional year of study. So you'll graduate with your bachelor's degree, and then just with one additional year of study, you'll earn your graduate degree as well. It's pretty cool. It's a cost-saving measure. It also helps you accumulate your credentials, which is never a bad thing. We can offer you all this, and I dare you to compare this. I encourage you. Dare is probably the wrong word. I encourage you to compare what we offer you with any other institution, large or small, and you'll see that ECAMS, by virtue of being one department all working together, all the 24 faculty working together to provide students maximum opportunity, you'll see that we offer you unmatched opportunity to achieve your goals and to round out your knowledge. In addition to that, we know that stuff doesn't occur just in the classroom. We have lots of extracurricular opportunities. Some of them are listed here. I already talked about the cyber defense and data cell clubs. We also have an esports club. In fact, our computer science student of the year, he recently created or helped create, was a prime mover in creating our new esports club facility where students can gather and play games together. It's a really cool place. Math Club, ACM, ACMW, KME, all really great societies or clubs to belong to. They help you build your leadership skills. They also look super impressive on a resume. Also, if clubs aren't your thing or not your only thing and you want to work one-on-one with a professor, all of our professors are engaged in research. We have PhDs in these areas, and we want to pursue the creation of new knowledge. We want to help create new knowledge in our field. And so we work with you, undergraduates, to help us pursue these research questions, and some of them are listed here. Lots of other institutions, including large state-sponsored institutions like where I attended, pretty much you had to be a graduate student to work on projects like this. But here at Lewis, you could start as a freshman working on projects like this and really contribute something and thoroughly develop and build out your interests. So that's a pretty awesome thing. We also have lots of internships because who wants to work at Chipotle to fund their tuition, right? I love Chipotle, don't get me wrong, but I wouldn't want to work there. You could work at a place where you can actually pursue, or you can actually apply what you learn in the classroom to real world problems, real world opportunities, and get your foot in the door to try to secure a full-time job, because that's why you are here, right? In addition to gaining knowledge, you're trying to pave your way toward a very bright future. And by working on an internship, there's lots of internship opportunities for our students. You can get a leg up on that. Bottom line is, we provide you big school opportunities in a small school setting. I'm not saying we're just some small little podunk university that you just see the same people over and over and over again. That's not true. We're kind of medium-sized, and so you'll see lots of people and meet lots of people with diverse interests, but at the same time, you're going to be taking advantage of opportunities that just can't be offered anywhere but at a large state institution. So you get the comforts and support of a small place, a relatively small place like Lewis, but you don't sacrifice anything in terms of your future opportunities, your chances to take what you know and expand it and grow upon it and apply it. That's what I'm so proud about. We've established over the past decade or so a track record of providing opportunities that you'd only find at the really, really large places, but we've packaged it here at Lewis for our own students. It's taken a lot of effort, but we've gotten really good at it, and our students benefited from that as a result. I'm so happy that you stuck with me through this fast-paced presentation. I hope you leave this presentation knowing that your future can be greatly benefited by being a student here, that you will be taken care of here. You'll have access to every opportunity you can possibly imagine here, and if there is an opportunity that you want to pursue that we don't currently offer, we'll work with you to give you that. Our job solely within this department and within this university more broadly is to help you reach your goals. We think there's nothing more important than that, and we will do everything we can to deliver on the promise to you that we make, that we will make you top-notch computer scientists, data scientists, computer engineers, electrical engineers, mathematicians, cybersecurity specialists, information technology specialists. Whatever you want to be in the field of computing or mathematics, we can give that to you here. So thank you very much for your time. The contact information for all the various program directors is here. They will respond to you immediately because that's how we are. I hope you enjoyed this presentation. Thank you so much for listening.